So we can have, so all of this is going to be time on your x-axis, okay? And just note that my breaths are not going to match necessarily, okay, just because me trying to freehand draw is not good. Okay, so we can have a pressure scalar, we can have a volume scalar, and then we can have a flow. Okay, so flow versus time, volume versus time, pressure versus time. Okay, so I'm just going to put some, these will all be baseline 0. Let's just say each of these is 10, 20, 30, 40. There's your pressure. For volume, let's say each of these hash marks is 100. Okay, and then for flow, let's say each hash mark is 10. Okay, everybody all right with that? Can you see okay from it?
Yeah.
Okay, just because the puppet and stuff. Okay, so first thing I want to look at is, let me look at my pressure. Okay, so when my breath is delivered, let's say my pressure comes up to here and comes back down. Okay, when I look at this, we're going to say that's roughly 30 of pressure, right? Okay, I'm just going to erase the time so I can. All right, if every breath right now comes up to 30, okay, it looks like it's constant, right? Okay, so this is where in a snapshot, you sometimes, we have to look at trends, okay? Because if this was 30 seconds out, well, yeah, they might all be the same, right? But when you go to get a test, they're gonna make it so that you'll know whether or not something is constant, okay? So let's say that this is constant for right now. And here's my volume. So this breath, okay, so is my volume constant or is it variable?
Variable.
Okay, so this is variable. Okay, and then here's my flow. Is that variable?
Oh. Variable.
Okay, so again, my pictures are not good. So when I'm looking to find out what the control is, okay, if it's pressure controlled, okay, then this pressure is constant, so P is the pressure, okay? Volume will be variable, and flow will be variable. Okay, so if I was given a diagram, or I'm looking at my ventilator, and this is what I see, I'm going to know immediately that this is pressure controlled ventilation, because that is constant. Okay, if I'm in pressure controlled ventilation, what's limited? Is the volume limited, the flow limited, or the pressure limited? Pressure. So in pressure controlled ventilation, pressure is constant and it is limited. Okay? So I am in pressure controlled, but is pressure limited because I set a limit. What's my limit?
30.
30. That's the most that ventilator is going to give. Okay? Hello. There's a handout here. You need it. Okay. The pressure is limited. Okay? So,
do you mind if I move these?
volume is variable.
Can I move it back?
Flow is variable. Okay? Alright. So,
Everybody move.
can I determine if I have time in here, 1 second. Just hypothetically, okay? Could I determine looking at this graph what my eye time is? Provided that they were equal, right? Yeah, because I could look at the distance from each time, right? And I could say, okay, here's my eye, right here is my eye time, right? So I could look at a scalar, and if I have the markings for time, I could determine what my eye time is.
So that's how you determine it, if only if the markings are given on the x.
You may, that's right, if on a scalar. You could look at it and determine what your eye time is, okay? Other than you look at the interface and it would tell you what your inspiratory time is. But I could look at this, and let's say the distance from here to here, again, is going to be 0.6 seconds. Okay, so I could get that information from that scalar, okay? Do I have any deflection down? Okay, so if there's no deflection, that means that the patient is not triggering. Okay, there's no patient trigger, there's no deflection down before inspiration starts. Okay, so I know that this is, the ventilator is triggering it. So what is, how is it triggered? Time, right? If the patient doesn't ask for a breath within a specific amount of time, it's going to automatically give it a breath. So let's say I have a respiratory rate dialed in of 16. Okay. How many seconds for each total cycle time from one breath to the next? How am I going to determine that?
60 divided by 16.
60 divided by 16. Okay. So I know 15 into 60 is 4, right? So what's my total cycle time? Close to 3.5? Somewhere in there, right? So let's say approximately every 3.5 seconds. Okay. So I know that if this patient doesn't ask for a breath within that certain time frame, the ventilator is going to give the breath. Okay. How is it cycled? When do we know? So cycle time is what ends inspiration, right? So how do we know what the cycle time is when we're in pressure controlled ventilation? What's the cycle? I put it for the inspiratory time, right?
Yeah.
Okay, so once it got to 0.6 seconds of inspiration, boom, it's done.
That's when inspiration ends.
All right, so it is time cycled.
Yes.
Right? It goes for a certain amount of time.
Okay.
And then it's done. Okay. If I have a 3.5 second cycle time in my eye time, so I'm just trying to put this all together on this one. So my eye time is 0.6 seconds. What's my E time?
We're going to subtract that from 3.5.
It's going to subtract that from 3.5, which is
2.9.
well, if my total cycle time,
1.9.
my total cycle time is, let's say, 3.5 seconds. If 0.6 of seconds is inspiratory time, the rest is
2.9.
2.9 seconds. Okay.
Wait, how would this you do?
Because 2.9 plus 0.6.
I saw that said 6.5. I saw the S.
Oh, sorry, that says S. Okay. What's my ID ratio? Okay, so we're going to go 0.6 is to 2.9. We want to get this to be 1, right? So we'll divide that by 0.6, and we'll divide this by 0.6. We're just putting a little math in there. But if I have time scalars on, time on there, there's no reason why I couldn't determine what my inspiratory time is. Okay? So 6 goes into 29, probably close to 4, because
Yeah.
6 in, so
I think it's 1 to 4.
24, 5 left over, 6 into 58, 1 to 4.8 roughly. Okay? So that's pressure control. Okay, does anybody need to do anything before I erase a little bit?
Sorry, just quick, where'd you get that 0.6 seconds from?
Up here.
I have a
know, but
question.
what is that?
She got it from
Inventory
Oh,
time.
just a number.
I just pulled that number out of my head.
So it has no relation to, the only time it comes into play is when you're trying to subtract it from.
Right, what I was looking, again, mine is not drawn to scale just
Okay.
because I'm
Yeah.
hand drawing, but if this is 1 second to 1 second, I just made a 0.6 in there.
Okay.
Is there gonna be a question like that where we need to be able to figure out the I to E ratio?
If I give you some factor that you can do that, yes.
No, but what I'm saying, so we're gonna have to do
From
that,
this?
To get one.
like, divide, yeah, like divide.
Well, if I ask you, this is the total cycle time, and a certain percent of your, here's your respiratory rate. All right, so I give you a respiratory rate of 24, okay? And your inspiratory time equals 0.8 seconds. I should be able
We
to
should be able
have
to
you
find our
figure
E time.
out,
Okay, so 24.
Your ET.
60.
okay, which then will get you to
Okay,
your
get that
IE ratio.
Divide minus that.
So do I
Okay.
expect that you can do that? Yes.
Yeah.
Okay, so my other question was, like, when I was just looking at that quick, before you did it out, 2.9 divided by 0.6, I was thinking it was like 4.5 or 4.6, so if I was off by a little bit.
You're not, no,
would
it's not
that-
gonna be that small,
Okay.
but no, it's not that small. The NVRC does not do that to you either. What they will do is they will throw in distractors like, again, if you didn't move your decimal point, or if you multiply, if you were supposed to use the plateau and you used your PIP, they would put an answer in that would correspond to that, but not off by point, no.
But it's not gonna be like in the answers. It'll be like 4.8, 4.6.
No.
Okay.
That's what I'm saying,
No.
like, if I had put 4.6, that wouldn't be wrong.
We pick the one that we get closest to what you're giving
Correct.
us. Okay.
Correct. Okay.
Did you say you're worried?
No, I'm not worried.
I thought you said you're worried, I was like, you should be.
Sounds
I
good.
heard that. I'm worried. Like,
That's what I heard too.
So I have a question.
Yes.
These waveforms that you just gave us,
Yes.
is this only pressure control?
Well, looking at it, does it look like pressure control? And the answer is yes.
Right.
Okay, but could I give you something that is different? Yes, and I'll get to that one.
Okay, that's what
I have a quick question about this, which is, I thought we didn't use flow cycling or whatever.
There is one mode of ventilation that uses flow cycling. I kind of mentioned it.
But it's not one that we typically use.
Should be in the notes.
Is that fluidic or something?
That's not what I'm
That's
asking.
something else.
No, I'm just asking like.
So on a
Fluid.
flow cycling
Not anything fluid yet.
tends to be more for like pressure support ventilation.
Yeah, but that's why I'm surprised that was just like, I thought we
Because you have to be
mostly
able to-
use pressure and volume, and I'm looking at this, and I'm like, well, why is it flow?
You mean for the answer?
Yeah, the answer is flow.
I have like 30 minutes.